Okay, this is, I believe, the material for 8.1b. Section 8.1 was divided into two assignments, A and B, due on different days. And this one, the part B, is about areas, and I think it's a lot easier than A because you don't have to do any inverse trig functions usually. Okay, so areas, and we're going to have two different formulas for the area of a triangle here. So the areas of a triangle theorem. So pretty much everyone, I think, knows that the area of a triangle is 1/2 the base times the height. But this can also be written as 1/2 A times B times sine of C. Notice those are two, A and B are the lengths of two sides, and C is the angle that those two sides make. And all I did there is I just wrote out H equals A sine C. So here's the basic setup. So you got this triangle, base times height, which I just called B. Then you have you have this angle C over here, and you have the other side that is next to C, that's adjacent to C. So A and B are adjacent to C. And then if you look at this, sine of C is opposite over hypotenuse, which is H over A. And that means if I solve for H equals A sine C. And so all I did was I just stuck A sine C in for the height, H. And you get this formula. And then I just put the A just to make this alphabetical. So it's a nice, easy formula to remember because it goes A, B, C. Just remember that A and B are the two sides adjacent to the angle C. Okay? So you use this if you're given two sides and the angle between them to find the area. If you're given the base and the height, you just use 1/2 base times height for the area. But if you're given the two sides and an angle between them, and you want to find the area, you can always use this to find the area. So, for example, find the area of the triangle with sides of length 1 and 3, an angle between these sides of measure 30 degrees. And again, I've got my calculator set in degrees, the mode in degrees, or I'll mess this all up. So I just draw a little picture, right? It looks something like that. And then I'm going to use my formula for area, 1/2 AB sine C. Right? And you can figure it out. Like this is just me figuring out so just figure out the height. Opposite over hypotenuse, right? Hypotenuse is 1 here. Oops. What did I do? Oh, this is just a standard triangle. 30, 60, 90 degree triangle. So I just made a standard size. So the height, well, let me see. What did I do here? So sine 30 degrees is 1/2. I'm calculating what sine of C would be. It's 1/2. So the area equals 1/2 times 1 times this one times 3. This is using this formula here. 1/2 times 1 times 3 times, and sine C, I just did this. This is a different triangle. It's just a 30, 60, 90 triangle just to figure out what sine C is. It's 1/2. And then if I take these and multiply them, I get 3/4. So the area is 3/4, which is a really nice number.